So today, I'm not in class, obviously, so there are three things that we're going to do. I should say number 3. And first of all, I'm going to let you guys ask homework questions, and obviously I'm not there to see what your questions are, so we're just going to go over questions that the other class had asked about their homework, and hopefully those are the same ones that you guys had. Thing 2, we're going to take some notes and do some practice with those concepts you take notes on. And then third, if you guys have time, you're going to start homework. So all of this is going to be done through this video, so you guys can pause and play and go at your own speed. So first homework question that the other class asked, that I figured you guys probably had a question on also, is I think this is number 17. 3 regular polygons meet at point A. How many sides does the largest polygon have? So what they're asking in this question is, how many sides does this red polygon have? So the way I'm going to approach this is I'm going to figure out what the measure of this angle here is so that I can work backwards and figure out how many sides it has. Now, to do that, I'm going to start out by finding the measure of this angle here. And this is an equilateral triangle. I know that because it says they're regular polygons. So if I take 180 degrees and I divide it by 3, I get 60 degrees. And so this angle has to measure 60 degrees. Now, this angle over here, I know that this polygon has 1, 2, 3, 4, 5, 6, 7, 8, 9 sides. So I'm going to find the sum of all of the interior angles. So 9 minus 2 times 180. 9 minus 2 is 7. So 7 times 180 is 1,260 degrees. So that's the total of all of the interior angles of that orange polygon. Now if I take that total and I divide it by 9, because there's 9 angles, I get 140 degrees, and that's each individual angle. So I know that this angle here measures 140 degrees. Now if you notice, the red angle, the black angle, and the green angle all form a circle. So together, they add up to be 360 degrees. So if I take 360 degrees and I subtract 60 and I subtract 140, then I get 160. And that gives me the measure of that black angle. So this is 160 degrees here. Now remember that the goal is to find out how many sides this polygon here has, this red polygon. So what I'm going to do is I'm going to remember what we talked about last class, where we said if we know the interior angle, then I know the exterior angle also. The exterior angle has to be 20 degrees because they're supplementary. Since all of the exterior angles add to be 360, if I divide that by 20 degrees, then I get 18. And that means that there must be 18 sides. So that orange polygon has 18 sides. Now the other question that the other geometry class had asked was number 7 from the next section, so we're going to look at that one too. Keep in mind, if you have more questions, you can ask your classmates or you can come see me later. So I'm going to start out by finding this angle here, the one that I just highlighted in, let me see, green. We'll do green. Okay, the way I'm going to find that is I'm going to say, all right, this is a 1, 2, 3, 4, 5, 6, 7-sided polygon. So 7 minus 2 times 180 will give me the total of all of those angles inside, which is 900. So that's the total of the interior angles. And if I take 900 and I divide it by 7, I get each angle individually. So that's 128.57 degrees. So this green angle here is 128.57 degrees. Now notice that this green angle and this one that I colored in blue and this one that I colored in blue, they form a circle, so they add up to be 360. So if I take 360 degrees and I subtract 128, then I get 128.7, then I get 231.43 degrees. Now that gives me both of those blue angles together. So I have to take 231.43, I have to divide it by 2 to get each one individually. So it's 115.72 degrees about. So that equals my angle D there. Now, if this angle here that is 128.57, well, this angle on the bottom is also 128.57 degrees. And angle C is supplementary to it. So if I do 180 minus 128.57, then I get 51.43, and that's going to be the measure of C. All right, so that's all we're going to go over for homework. So next up are notes. Now, the beginning of the year, you guys got something that looks like this, and some of you might have it, some of you might not. The sub should have given you guys a copy of this if you don't have your old one. So this whole rest of this unit is all about quadrilaterals. So quadrilaterals only have 4 sides, and all of these shapes are quadrilaterals. So trapezoids, parallelograms, rectangles, rhombuses, squares, they're all parallelograms. Or sorry, they're all quadrilaterals. They're all types of quadrilaterals. Today we're going to focus on trapezoids and kites. You guys have learned the basic properties of these shapes, but we're going to talk about them more specifically today. So let's start out with trapezoids. Actually, let's start out with kites. So when we're looking at a kite, the diagonals of the kite are perpendicular. So you guys can fill this in. And the way we mark that in our diagram is with the right angle, a little box. So all 4 of those are perpendicular. 2 pairs of consecutive sides are, and you guys should know this from earlier this year, they are congruent. So these 2 are congruent, and separately these 2 are congruent. Angle ADC and angle ABC, so that's this angle and this angle, they are congruent. They kind of look congruent, well, they are congruent. So those 2 angles are congruent. Next, AC. So this segment down the middle, AC, what does it do to angle DAB at the top and angle DCB at the bottom? Well, it bisects it. So it bisects these angles. So at the top, it cuts it in half, and at the bottom, it cuts it in half. And notice I'm using 2 tick marks at the top and 3 at the bottom, so I don't confuse it with my other angles that I've already marked. Okay, last but not least, AC does what to DB? Well, this segment that runs up and down, it bisects this segment that's going side to side. So this guy is cut in half here. Okay? So that's kites. Now let's move on to trapezoids. So with trapezoids, we have 2 types of trapezoids. We got regular trapezoids, and then we have isosceles trapezoids. So in any trapezoid, for it to be a trapezoid, exactly 1 pair of opposite sides have to be parallel. We mark that with the arrows here. Now, because isosceles trapezoids are types of trapezoids, we say that exactly 1 pair of opposite sides are parallel. And the non-parallel sides are congruent. So I'm going to mark that in my diagram. These 2 sides are congruent. The diagonals from B to D and from A to C, those are congruent. And I'm going to mark that with 2 tick marks here on AC and 2 tick marks here on BD. Now, ABC, this angle here, and BCD, what do they look like they are? You can probably guess this from the picture, but they are congruent. And then BAD on the bottom and CDA, they are also congruent. Now the one that's a little bit harder to see is this last one. So I'm going to draw a picture here of 2 parallel lines, and we can imagine that there's a trapezoid inside. Well, think back to last unit, or maybe it was a unit before, I don't remember. But this angle and this angle, so ABC and BAD, those are consecutive interior angles. And if you think about those colored dots that I had you guys draw, they would be the opposite color. So like these 2 angles are opposite colors, and that means they're supplementary. So those 2 angles are supplementary. They add up to be 180 degrees. And the same thing happens over here. These 2 angles are supplementary. Now this part in the bottom, property 6 and 7 that talks about mid-segments, we're going to get to later in the later in the unit. So you guys can just kind of hold off on that for now. So what I want to do now is I want you guys to pause the video. I want you to take out this worksheet, and I want you to try as much of it as you can, and then play the video again and check your answers, and look at the problems that you didn't know how to do. Okay, so answers. Name the bases of the trapezoid PQRS. So one base is PQ, and the other base is SR. Name the legs of the trapezoid. So the legs are PS and QR. And notice I put a line segment over top, because if we don't put the line segment, it means we're talking about measurement and not the actual physical segment. Name 2 pairs of congruent angles. Okay, angle P is congruent to angle Q, and angle S is congruent to angle R. Name a pair of congruent segments. Well, because it's isosceles, PS is congruent to QR. So that's 1 through 4. So now let's come down here and let's look at number 5. So first thing on number 5 that I would do is label the information that's given. So measure of angle A is 2x degrees. Measure of angle B is y over 2. Measure of angle C is 2y. And D is 4x over 5. So when you set this up, you need more than one equation, because if you just add them and set them equal to 360, you have 2 variables. So what you need is a system. So you can either add A plus B and set them equal to 180, and add C plus D separately and set them equal to 180, or you can add all 4 and set them equal to 360. So you have 3 options to get 2 equations. You need 2 equations so that you have a system, so that you can use substitution or elimination. So I'm going to choose to add A and B and set them equal to 180. So 2x plus y over 2 equals 180. And then I'm going to also add 2y plus 4 over 5x equals 180. Now, I don't want to deal with these fractions here. So what I'm going to do is I'm going to multiply this whole equation by 2. And that's going to give me 4x plus y equals 360. And similarly on this equation on the right, I don't want to deal with this 4 in the denominator, or sorry, the 5 in the denominator, so I'm going to multiply by 5. And that's going to give me 10y plus 4x equals, and 180 times 5 is 900. So now I have this nice system of equations. I'm going to put them one on top of the other. 4x plus y equals 360. 10x, and we line them up. 4x plus 10y equals 900. Now what I'm going to do is I'm going to multiply this top equation by -1 so that I can eliminate the 4x, because I'm choosing to do elimination instead of substitution. So that gives me -4x minus y equals -360, and the bottom equation stays the same. I'm going to add them, so these cancel, and this becomes 9y. And then 900 minus 360 is 540. And then divide by 9, and I get y equals 60. Now that I know y, I can plug it back in. And I'm going to choose to plug it back in here, just because that's easiest. So 4x plus 60 equals 360. Subtract the 60 from both sides, and I get 4x equals 300. Divide by 4, and I get x equals 75. So there's my x, and there's my y. Now the problem also asks you to actually solve for b and a. So what I'm going to do is just multiply 2 by x, which is 75, and I get 150 degrees. For b, I'm going to take my y value, which is 60, I'm going to divide it by 2, so I get 30 degrees. For c, I'm going to take my y and multiply it by 2. And then for d, I'm going to take x, I'm going to do 4 times 75 divided by 5, and that equals 60 degrees. So you can double check that the angles on top of each other, so like 150 plus 30, they add up to be 180, and they should. And then 120 plus 60 should add up to be 180, and it does. So that's good. Alrighty, now let's look at the last one on this page, number 6. So number 6 asks for the perimeter. And we need to figure out what x is. So what I'm going to look at here is simplifying, is putting this little dotted line in and figuring out, using Pythagorean theorem, what x could be. So I'm going to call this 4, because this length here, this vertical 4, is the same thing as that. And this guy here, from here to here, is also 3. So if that's 3 and the whole thing's 7, this part here is 4. So now I have this right triangle, and to figure out x, I can just go 4 squared plus 4 squared equals x squared. So I get 16 plus 16 equals x squared, which gives me 32 equals x squared. And now I'm going to take the square root. So the square root of 32, when you add a square root, you need to add plus or minus. So I get that x equals positive square root 32, and x equals negative square root 32. The negative one we're going to cancel because we know that we're using the length of a side of this quadrilateral. So it has to be positive. And I'm going to go ahead and simplify that radical. So square root 32, same thing as 2 times 16, which is 2 times 2 times 8. Which is 2 times 2 times 2 times 4, which is 2 times 2 times 2 times 2 times 2. Okay, now simplifying, I know that 2 times 2 is 4, and the square root of 4 is 2. So out comes a 2 for that. And same thing here, out comes another 2. So 2 times 2 is 4 on the outside, and I'm left with this 2 on the inside. So I get that x equals 4 square root 2. So now for the perimeter, my perimeter is 3 plus 4 plus 7 plus 4 square root 2. And so that equals 14 plus 4 square root 2. And I'm going to leave it exact like that. All right, moving on. On the back, we've got kite questions. So, measure of GKJ is 90 degrees. That is true. HJ is congruent to IG. HJ and IG, that is false. The diagonals are not necessarily congruent. Angle HIJ is congruent to angle HGJ. That is true. HJ bisects IJ. Oh, they bisect each other. That is false. Only IJ is cut in half. IG is cut in half. HJ is not cut in half. Okay, angle IHG is congruent to IJG. That's false. And HJ bisects IG. That is true. Now, on number 17, refer to this kite. PQ equals QR equals 10. So this is 10 and this is 10. PR is 16. So the whole thing's 16. This side's 8 and this side's 8. This is 90 degrees here. And RS is 12. So it wants to know TR. We already know TR is 8. QT. So to find QT, I'm going to use the Pythagorean theorem because we have a right triangle here. So I'm going to say x squared plus 8 squared equals 10 squared. So I get x squared plus 64 equals 100. When I subtract the 64, I get x squared equals 36. Take the square root. When you add a square root, you add a plus or minus. So x equals square root 36 and negative square root 36. So we get x is 6 and negative 6. And I know that I don't want the negative 6 because we're talking about the length of the side of this quadrilateral. So x equals 6. So my QT is 6. Okay, TS, and it wants it in simplest radical form. So again, TS is here. I've got a right triangle. So 12 squared equals 8 squared plus x squared. So we've got 144 equals 64 plus x squared. Subtract the 64 from both sides, and we get 80. So 80 equals x squared. Square root. When you add a square root, you add a plus or minus. So we get x equals positive square root 80, and x equals negative square root 80. We don't want the negative answer because we're talking about the length of the side of a kite. And I'm going to simplify my square root of 80. So square root of 80 is 2 times 40, which is 2 times 2 times 20, which is 2 times 2 times 2 times 10, which is 2 times 2 times 2 times 2 times 5. So I got a pair of 2's here and a pair of 2's here. For each pair, one comes out. So we end up with 4 root 5. So TS is 4 square root 5. Simplest radical form. Now, for QS, all I'm going to do is I'm going to add 6, which was this length, plus 4 square root 5, which was this other length. But it wants it rounded, so I'm just going to plug it in my calculator, and that gives me 14.94. And those are all the questions, so you guys can go ahead and get started on your homework, which is in the book. You can check the website for the page numbers.